It's the fastest, most extreme, and most exclusive production super sports car in the world. The French-made vehicle shoots along the road at a top speed of 420 kilometers an hour. This hypercar scratches at the boundaries of physics, a motorized superlative.
It is this ambivalence between beauty and beast.
To awaken the beast in this ultra-powerful engineering work of art, the developers have made the best even better.
You start working where others have stopped.
The mission, a hyper sports car with 1,500 horsepower and a top speed of 420 kilometers an hour.
The whole world said you'll never manage to cram so much power in a car.
The whole world was wrong, but the enormous power concealed in this rocket poses new challenges.
You have to be sure that you've still got enough weight on the front that it won't take off.
To ensure a healthy body mass index, the Alsace engineers have fitted the all-wheel drive vehicle with lots of carbon, titanium, and magnesium.
Lots of things you would normally only find in Formula One cars.
And the elegant top athlete with the 16-cylinder engine is anything but normal. The design engineers all agree about that.
Can you compare the Chiron with another vehicle? No.
God created heaven and earth, and the French created the Bugatti Chiron. The spearhead of vehicle construction is located in Molsheim, France. The Bugatti Hyper Sports Car Manufactory. These record-holding dream cars have been built on the site of the former family estate for the past 110 years. Built in 2004 in the form of a company logo, the Alsatians lovingly refer to the new production building as the Dream Factory. Inside, 20 employees assemble up to 16 vehicles at the same time at 12 stations. With these production figures, Bugatti is part of the haute couture among vehicle manufacturers. The Bugatti Chiron is the flagship of the current collection.
It's a lot of manual work. It's like in a Formula One racing stable. Everything's handmade at various stations. Some 300 people work at Bugatti. Engineers, sales representatives, and purchasers. People who share a passion to develop, build, and sell super sports cars.
It takes 2 months until the French have assembled around 2,600 individual parts to form a new motorsport work of art. The Chiron's hood conceals pure performance. The world's most powerful production engine has 16 cylinders and a displacement of 8 liters. This enables the Bugatti to reach its record-breaking speed of 420 kilometers an hour. 4 offset operating turbochargers accelerate the 1,500 horsepower projectile from 0 to 100 kilometers an hour in just 2.4 seconds. Instead of a classic production line, there are 4 special stations in Molsheim. They each contain 2 independent lifting platforms. Because the sports coupe is made up of 2 parts, which the employees marry with one another during production. 3 mechanics always assemble what is called the Chiron's rolling chassis strictly by hand, the drivable naked vehicle skeleton. An expensive delivery is waiting at the Bugatti cargo ramp. This body component heralds the construction of a new all-wheel drive behemoth. The monocoque is a hollow driver cockpit and is made entirely of carbon fiber reinforced plastic, or CFRP. 4 steel journals now rise up out of the gleaming shop floor. 2 workers install an assembly platform on them. The production crew then heaves the 150-kilogram carbon framework onto the platform. Each material that the Bugatti design engineers install fulfills a specific purpose.
The materials we use at Bugatti are the finest, but also the lightest available. We use lots of magnesium, titanium, carbon, and aluminum, lots of things that you would normally only find in Formula One cars. There are no miracles in technology. Our Bugatti Chiron is capable of topping 400 kilometers per hour and can accelerate from 0 to 100 in less than 3 seconds. We're talking about numbers and performance that are somehow unreal. But this simply represents a lot of work at the development and also at the production level to ensure this performance is always achieved.
The technicians install the wiring harness inside the carbon cockpit. The harness consists of 2.5 kilometers of cables and is the nerve system of the chiron. It connects the vehicle's 20 control units. The mechanics fasten the electrical wires to the monocoque with titanium screws. Like all of the other elements in this racing machine, the wiring harness is also designed as compact and light as possible. The rear frame of the exclusive coupe is assembled on the second platform. But first, the workers move the assembly frame to the heart of the Bugatti, the 640-kilogram 16-cylinder engine. Due to the size and the enormous weight of this unit, the assembly platform comes to the engine in Molsheim. The mechanics use a crane to put the German-built high-performance power plant down on the assembly platform. The engines are manufactured at the Volkswagen engine plant in Salzgitter. Covering 2.8 million square meters, this site boasts its own Bugatti department. Whoever works here belongs to the absolute elite among engine mechanics, as the 16-cylinder is considered to be the holy grail of engines. 2 technicians need 1 week to build one of the 1,500 horsepower quad-turbo engines.
We build a car that does over 400 kilometers an hour and drives elegantly to the opera in the evening. To do this, you need not only a car that can achieve this, but also an engine that's capable of driving in the summer and winter, in cities, traffic jams, as well as on racetracks, and that's something of a challenge. Formula One teams are good at building racing engines with lots of power, and Volkswagen is adept at building good engines for the road, for golf. But this combination of 2 worlds is Bugatti's specialty.
Christened production nests by the technicians, the 4 workplaces in the engine department are also special. Each station is structured so that a complete unit can be built here. The experts manufacture a total of 3 of these powerful heavyweights per week. To make the engine as compact as possible, 8 cylinders are distributed over each of the 2 V-shaped banks, thus creating an artificial W engine with 16 cylinders. The W16 achieves its maximum acceleration with 4 high-performance turbochargers. Via a turbine, the quartet compresses the air intaken at the front of the vehicle and presses it into the combustion chamber in stages. Thanks to what Bugatti calls sequential turbocharging, Turbo 3 and 4 cut in at 2,800 RPM. This prevents turbo lag and therefore ensures constant power. At Production Nest 2, a new crankcase is ready to be assembled. A mechanic has just installed the pistons in the 16 cylinders and connected them to the crankshaft. Before the engine builders continue their work, they use an electronic torque wrench to simulate engine operation. For instance, this allows the workers to check that the piston stroke does not lead to friction on the cylinder wall. Otherwise, serious engine damage called piston seizure could occur later while driving. The Chiron's engine is made up of around 3,700 individual parts. The technicians pre-assemble individual components at workplaces next to the assembly stand. This worker is assembling various engine elements. Here, he is fitting a fuel pump. Later on, it will deliver the required quantity of fuel to the engine. The worker then installs the alternator. Its task is to generate electricity for the starter battery and other electrical components. At the same time, his colleague prepares the oil pan for assembly. it has to be absolutely leak-tight, because later on the pan contains the engine oil needed to lubricate the 16-cylinder engine. This is why the technician now takes it to an automatic station. Two different processes take place here. First, a special oxygen plasma cleans the surface of the pan. Although the engineers pay strict attention to cleanliness, there is still a fine layer of dirt on the components. The station then applies a black sealant onto the edge of the magnesium pan. Once the sealant has been completely distributed, the technician has 20 minutes to assemble the component. To do this, he positions the oil pan over the crankshaft onto the lower side of the engine block and seals it. Only specially trained technicians are permitted to build the Chiron engine. Whoever has successfully completed the additional 2-year training can justifiably feel proud.
I'm one of a total of 8 technicians worldwide who are permitted to build this engine in series. Of course, that makes you very proud. It's like you made your hobby your vocation.
You can already get a sense of the enormous dimensions of the combustion engine at Station 3. The quad-turbo engine draws its power from the ignition of a fuel-air mixture. These camshafts ensure the correct mixing ratio. Driven by the engine's chain, the cams rotate around their metal shaft and thereby press alternately on the valves of the individual cylinder heads. This enables them to open and close in a specific stroke. The mechanics bolt 2 of these 1-kilogram engine components per cylinder bank. The W16 engine in the Chiron has a total of 4 camshafts. So that the mixture can ignite, the engineers now insert 16 spark plugs into the cylinders. They supply the final pulse for starting the engine. They also influence the 4-stroke engine's performance, consumption, and pollutant emissions. The plugs generate a powerful spark between 500 and 3,500 times a minute. The resulting explosions set the ranks of pistons in the cylinder bank in motion. The stripped engine, meaning all of the components needed to operate the drive unit, is now complete. However, the massive power plant is considerably bigger when fully assembled. All further attaching parts are true to the Bugatti philosophy of more power and maximum performance. The final dimensions of the engine in a Chiron are 4 times those of a standard passenger car engine. Since 2005, the engines for the French luxury brand have been hand-built at the plant in Salzgitter. Even when the company was founded in 1909, the engine blocks were cast by hand at Bugatti. Back then, the engines for the first models were produced at the plant premises in Molsheim. Although working conditions 110 years ago were certainly tougher, the basic structure of high-performance engines has barely changed. With his racing and luxury cars, the Milan-born company founder was considered to be a legend of European automobile history, even back then.
Ettore Bugatti developed and built vehicles that are still icons of motoring history today. Cars like the T35 or the Bugatti Atlantic. Ettore Bugatti was a perfectionist and did incredible things here in this plant back in the 20s and 30s. The simple fact that we call our plant an atelier rather than a factory is quite a statement in itself. The entire Molsheim site here in Alsace, France, is unique for an automotive manufacturer because it exudes pure history, and no other manufacturer can offer that.
The name Bugatti stood for revolutionary ideas from the get-go. In 1933, the Milan-born visionary even built a rail bus with a top speed of 200 kilometers an hour. Ettore was often laughed at for his unconventional ideas. But in the 1920s, Bugatti's super sports cars achieved worldwide fame, thanks above all to their record number of 2,000 race victories. The name Chiron also played a role back then.
Chiron was a racing driver in the 1920s, a very successful one, who won a lot of races with Bugattis. And today the Bugatti Chiron, named after him, is the ultimate hypersports car. And the engine is at the heart of it, an 8-liter engine with 16 cylinders and up to 1,600 horsepower.
However, the objective of building the world's fastest production sports car in the form of the new Chiron was viewed very critically by the industry.
The whole world said you'll never manage to cram so much power in a car. But a displacement of 8 liters over 1,000 horsepower is a conventional task. You add turbochargers to it, and at some point you achieve that power, and then you're faced with a big problem in that you can't find a test bench anywhere in the world that can cope with this power.
But the engineers solved precisely this problem. On an internally developed test stand, they put the 8-liter engine through its paces until the manifold glows. Once completed, the engineers test the power output and, above all, the durability of each power plant. Behind the roughly 30-centimeter thick safety walls of the test booth, the team has strapped the combustion engine down and coupled it to a dynamometer. It's able to demand the engine's full output of 1,500 horsepower at 6,700 revolutions per minute. The stress applied on the test bench is significantly higher than during vehicle operation.
An engine is tortured for up to 1,000 hours on the test bench. That's hundreds of thousands of kilometers on the road. If an engine has survived that, it can survive anything.
A gigantic blower cools the engine during the test. Special sensors measure a total of 500 different values, which the testers check on the monitor. The tests were also an important part of developing the 16-cylinder engine, because the results were incorporated into its 3D model and helped the design engineers to detect possible critical areas. It took 3 years to develop the Chiron's power plant. Often, optimization requirements also arise due to legal specifications. Corresponding measures that the engineers plan on their screens then have to be verified on the real component. During a special auditory test, an acoustic engineer checks whether the exhaust system simulation matches reality. To do this, the sound expert applies a pure tone to the exhaust tailpipes using a loudspeaker. The sound causes the air particles inside the system to vibrate. The engineer records the resonance using a microphone. This allows the sound and the volume to be viewed on the monitor. By 2026, passenger car driving noises have to be reduced to 68 decibels. That's roughly the same as a television at low volume. At the same time, however, the engine sound must not suffer. The acoustic factors are particularly crucial to the experience of driving the Chiron.
What the driver's hearing is an entirely unconscious process. Nevertheless, he needs specific information. He wants to know when the road changes. He wants to know whether the engine RPM is too low or too high. He wants to know what the absolute vehicle speed is via the wind noises. If any of this information is missing, the vehicle is perceived as unharmonious. The rolling noise is relevant, how the windows are constructed, how well the chassis is insulated from the cockpit. All of this characterizes the overall noise perceived by the driver. This all has to be composed to form a consistent concert to achieve a positive experience in the vehicle's interior.
And who better to test this experience in new models than a genuine motor racing expert? The former Le Mans winner, Andy Wallace, is Bugatti's test driver. He has already driven around 100,000 kilometers in the luxury sports car from Molsheim. An absolute dream job. The Briton also provides the developers with direct feedback about the Chiron's performance and handling from the driver's cockpit.
If you like cars and you can maybe dream about supercars, this one is the top, the very top of the pile. And for me to be able to drive this car every day, if you told me that when I was 7 years old, I never would have believed you. So for me, it's fantastic.
However, Wallace will be thinking about the following drive for a long time to come. With this Chiron, the Briton will set a new speed record of 304.773 miles an hour, or 490.484 kilometers an hour. The Chiron Super Sport 300 Plus pre-production model offers an additional 100 horsepower, totaling 1,600 horsepower. On the test track in Iralessin, Germany, its tires will be rotating no fewer than 4,100 times per minute. This would be the first time in history that a production vehicle breaks the 300-mile-an-hour barrier. And off he goes. Andy Wallace floors the accelerator and is already doing 100 kilometers an hour 2 seconds later. Covering around 11 square kilometers, the test site lies at the center of a pine forest. Curves and straights follow in quick succession. This makes it difficult to keep the vehicle on track.
You're constantly turning to go straight, and this is at the same time that you're traveling 136 meters per second. Everything's coming at you really, really quick. So the senses coming into you are crazy, and you have to try and keep all that under control. And it's not something you do every day, so it's not something you can practice. You just end up doing it, and it's pretty impressive.
3.5 kilometers ahead of the record. The Chiron is still picking up speed. The down thrust, also called downforce, on its rear end increases. This causes the front end to lift. The Bugatti uses a complicated aerodynamics concept to counteract the principle that helps airplanes to take off. After 70 seconds at full throttle, Wallace breaks the record.
Wow, guys, what a fantastic car. Dankeschön, grazie, merci. I can't thank you enough.
In the atelier in Molsheim, France, a worker transports an important component to a newly arrived engine block. Two mechanics now couple this 7-speed direct shift transmission to the power plant. The automatic shift unit ensures constant power output when shifting gears. Because one clutch closes at the same time as the other is opening, the automatic transmission ensures consistent tractive force. The workers then take the new drive unit to an assembly station. Covering 1,000 square meters, the shop is more akin to a sterile operating room than a vehicle workshop. There are no oil stains or rubber abrasion from car tires on the highly polished synthetic resin floor. The two-seater's engine alone costs around 300,000 euros. Over the next few hours, the rear section of the vehicle will be built around the high-performance unit. To do this, the Bugatti surgeons first attached the chassis to the side sections of the body alongside the lifting platform. They are also made entirely of carbon. A technician first bolts the independent wheel suspension elements to the carbon fiber framework. The hypercar has no rigid axle. This means that each wheel can be actuated individually and therefore has maximum grip or contact surface on the asphalt. As a result, the 2-ton Bugatti remains stable even when taking tight corners on a wet road surface. Depending on the driving situation, the onboard computer regulates the 4 wheel's toe and camber to ensure this. The entire substructure of the extreme sports car is adaptive. These suspension struts that the technician is installing can also be optionally set to a family car or racing car profile. The hardness of the damper, called its characteristic in technician jargon, is adjusted by allowing more or less oil to flow from one shock absorber tube to the other. The worker now mounts the finished side section on the engine block with his colleague. Building a new hypercar in the exclusive French manufactory is complicated and involves 2,590 individual steps. Good timing in the production sequence is absolutely crucial.
We always assemble 16 vehicles at the same time, using 20 employees. These include 7 mechanics, 4 coach builders, 3 technicians who assemble the vehicle interior, 2 painters, and 4 electricians. This team of 20 persons assembles a vehicle in 8 weeks. This needs to be well organized to avoid delays and ensure that the customer's satisfied.
Next, the supercar is fitted with its exhaust system. When the engine is running, temperatures as high as 500 degrees can be reached at the rear muffler. That's why this employee first installs a galvanized heat shield on the exhaust pipes. His colleague carries the gigantic exhaust to the chassis. Later on, 6 tailpipes rid the chiron of everything the 8-liter power plant spits out of its 16 cylinders. The team now fastens the enormous titanium muffler to the rear end of the emerging Bugatti. Titanium is light, ductile, and particularly heat-resistant. This is important so that the material does not crack under the extreme heat. The crew then clads the mid-engine with further elements to protect it on all sides.
We've now fitted all the parts around the engine, and once we've assembled, bolted, and connected everything, we can connect it to the front section, to the monocoque. This is what distinguishes us from classic mechanics in a garage. This really is assembly. We start with nothing and build the vehicle. And that is the difference between this and other vehicles, because this is an exclusive car, an extremely powerful vehicle. You have to work very precisely, you can't afford to make mistakes.
It's now becoming cramped in the monocoque too. Such a cockpit framework contains a total of 320 square meters of carbon. Placed end to end, all of the individual carbon fibers are 9 times the distance from the Earth to the Moon. A mechanic is now fitting one of the chiron's 2 differentials on the underbody of the chassis element. A computer tells him whether he has tightened all of the bolts to the correct torque and stores his production data in the system. The differential compensates the differences in wheel speeds when cornering. The wheels on the inner side of a corner cover a shorter distance than the outer wheels and therefore turn more slowly. Conversely, this means that the outer wheels require more power to cover the greater distance in the same time. A transmission inside the differential distributes the engine's power to the hypercar's individual wheels to varying degrees. Bringing the vehicle to a stop from its top speed of 420 kilometers an hour poses a major challenge for the brake system. The temperature can soar to 1,100 degrees when the supercar is braked. That's as hot as glowing lava. The men in the atelier therefore also fit a heat shield on the wheel suspension before installing the carbon ceramic brake discs. One of the sport brake discs weighs around 8.5 kilograms. Its caliper is the world's largest 3D printed titanium part. The Chiron currently has the most powerful brakes of any production vehicle worldwide. But this is not enough for the French.
I have here a design model of a brake saddle that we don't have in production yet, but we're testing it. Where you see material on this part, that's where the load path is happening, and that's where the strength needs to be on this building part. And where there is no material at all, there's also no load on the part. That means you can save that weight. It doesn't need any styling lines, but just the pure genius of the technical development is aesthetically so interesting and so intriguing that you leave well enough alone and apply it to the car. And this is really fascinating in itself.
The Bugatti crew assembles the front of the monocoque. This worker is fitting a guard for the chiron's sensitive electronics and mounting a control unit for controlling the vehicle dynamics. Later on, this so-called ESC helps the driver to keep the hypercar under control. By specifically braking individual wheels, for instance, the system prevents the vehicle from skidding when cornering at high speed. Over a period of 4 days, the team has installed 2,600 components at the special stations. An important ceremony is now on the agenda for the front and rear frames. Like everything at Bugatti, the marriage of the monocoque and the rear section in the Molsheim Luxury Atelier is something special. The crew first moves the platforms to the same height. The frame sections have to fit precisely in one another. In the worst case, the construction would have to be taken apart again to adjust individual elements. The three men now maneuver the 750-kilogram rear section to the monocoque. The iron wave accompanies the rear section to its better half. The team gathers its strength again for the last few centimeters. The fact that the chiron's chassis consists of two parts offers several advantages. So that the driver's cockpit is subsequently stable and therefore as safe as possible, the front section is made completely of carbon. However, the entire body is too big to be built entirely of this lightweight material. The vehicle is also designed so that the rear end can tear off in the event of an accident. Because if the engine catches fire, things quickly become dangerous. A total of 14 titanium bolts that the technicians are now fastening ensure that the front and rear sections are joined firmly together. On the underbody, two Bugatti mechanics now fasten the lines for the luxury car's operating fluids. Later on, engine and transmission oil as well as brake fluid will flow through them. The chiron's fuel hoses are made of tough polyamide plastic. The airstream at the front end of the vehicle ends up in these two carbon chambers. Via special filters, it flows into the 4 turbochargers compressors, where it is then forced into the cylinders at increased pressure. This means that there is more air and therefore more oxygen for combusting the fuel. The result is a more powerful explosion, higher pressure, and thus linear engine power output. The Bugatti's special tires are custom products from Michelin. With a width of around 36 centimeters, the tires have to withstand enormous forces during vehicle operation. At maximum speed, the wheels rotate around 50 times per second. This means that 7 metric tons are pulling on their tread. That tortures the tough rubber. The chiron is fitted with semi-slicks. They have a lower tread depth and therefore less weight. As a result, the tires offer plenty of grip despite the enormous centrifugal forces. A set of the semi-slicks costs €9,250. The hypercar is now filled with its operating fluids. An employee feeds the vehicle with engine oil, brake fluid, and 40 liters of water. When the car is driving, this is circulated 20 times per minute by the pump to prevent the engine and powertrain from overheating. The mechanic then fills the hypercar's tank. The fuel tank can hold 100 liters of gasoline. The chiron consumes an average of 22.5 liters every 100 kilometers. The Bugatti's rolling chassis now proceeds to its first test station in the Atelier's annex. The French had to develop a new dynamometer for the Chiron, which is capable of withstanding the hypercar's 1,500 horsepower. This means that the Bugatti dynamometer is also the most powerful of its kind in the world. A technician first attaches the 2-ton vehicle to these wheel clamps. The safety flap of the acceleration roller then drops down and the ventilation system shafts rise up. Then he fastens a fresh air hose to the front of the chassis so that he doesn't suffocate in the cockpit. His colleagues have provisionally fitted a windshield in the luxury car. The technician now also fits 2 doors to establish the most realistic conditions possible in the vehicle interior. Now, the high-performance car can show what it's made of for the first time. The employee accelerates up to 200 kilometers an hour. The sports car has to complete a total of 342 tests. He tests the engine, the transmission, and all vehicle dynamics programs for 3 hours. The Bugatti covers around 60 kilometers on the dynamometer. This Chiron has passed all of the tests. The employee releases the vehicle from the wheel clamps and removes the doors. His colleague now takes this superlative on wheels to the next station. Here, the Chiron is dressed in its Sunday best. To do this, the exterior crew pre-assembles the body parts next to the lifting columns and cleans and polishes them. The individual elements are large and fragile. That makes this work step extremely demanding.
We get parts that are perfectly painted and absolutely flawless.
Sans aucun défaut.
What is then complicated for us is to install these parts without damaging them. That's not easy. We have to take great care, work very precisely, and attach the parts so that everything is perfect for the final quality check, and the customer is ultimately satisfied.
It takes up to 4 days to clothe the vehicle. Installing the windshield is particularly complicated. It has to be positioned exactly and be absolutely watertight. To install the windshield, the technicians first coat the body with a primer. They apply a special adhesive onto the safety glass. The workers then place the windshield onto the vehicle frame using a vacuum lifter. The 2-component mixture reacts to form a particularly elastic resin and ensures that the glass can withstand even strong vibrations. Each Chiron is a unique work of art and can be completely individualized. The choice of material and color combinations for styling the vehicle is virtually unlimited. Ettore Bugatti himself once said perfection is never achieved. But to this very day, designers have been attempting to create the most perfect models with a mixture of unbridled power, technical beauty, and flawless elegance. To accomplish this, they work closely with the developers, because the paramount objective of motorsport artists is form follows performance. The striking C of the Bugatti DNA on both of the Chiron's flanks therefore also serves a specific purpose.
To a lot of people, that line looks like a stylistic idea of a designer, or, oh, because it looks so nice and romantic, let's just do it like that. It's exactly the opposite. The performance need from the engineer was as much air intake along the whole body side of the car was needed to feed all that pressured air into the engine compartment for cooling purposes. And for me, that is always the most authentic way as a car designer that I can answer the need of a technical problem with a stylistic combination.
Bugatti's vehicle DNA has constantly evolved according to this principle. Due to its shape, the exclusive coupe's extraordinary radiator grille has been nicknamed the horseshoe. In 1910, however, the first Bugatti model, the Type 13, had an egg-shaped front end. To improve the vehicle's aerodynamics and cool the increasingly larger engine, the designers adapted the look of the grille to the technical requirements. Probably the only part of a Bugatti whose shape or weight has not been optimized is the brand logo. This chiron in the atelier in Molsheim is now almost fully dressed. Each paneling element also plays a role in the complex aerodynamics. This consists of active and passive systems. All of the components integrated into the paneling are passive. The active modules can be actuated and adjusted to the position and speed of the vehicle. The super sports car is a master of aerodynamics. The air curtains at the front specifically guide the impacting air pressure through and past the vehicle. This presses the chiron onto the asphalt and cools the brakes. The 1.5-meter wide rear spoiler adapts fully automatically to the respective driving situation. 0.8 seconds after applying the brakes, the adaptive wing tilts to an angle of 49 degrees, thus acting as an extremely effective air brake to decelerate the Bugatti. The hydraulic spoiler is the last of a total of 55 panel parts that the mechanics fit onto the luxury car.
We regulate the angular position of the rear wing, the diffuser flaps, and the underbody via the speed range. This is how we ensure that the vehicle is safe in every driving situation and that the focus is on straight-line stability or agility.
In 2017, the air brake played an important role in another world record. Formula One winner Juan Pablo Montoya accelerated the chiron to 400 kilometers an hour from a standing start. After 700 meters, he was already doing over 300 kilometers an hour. In the 33rd second, the Colombian racing driver reached the 400 kilometer an hour mark. He brought the 2-ton vehicle to a standstill again after 491 meters in just 9.3 seconds by fully applying the brakes. Montoya took exactly 41.96 seconds and covered a distance of 3.1 kilometers to accelerate the chiron up to its top speed and brake it. That was a new world record. So far, no other vehicle has managed to achieve this outstanding performance. A force of 850 kilograms presses on the rear wing during maximum braking from top speed. This brings the hypercar's rear axle to its knees. During this sharp braking maneuver, forces of around 2G act on the vehicle and the driver. A further chiron has now been fully assembled at the Bugatti premises in Molsheim, France. So that it's not scratched, during its first test drive, the employee is covering each millimeter of the hyper sports car with a protective film. Covering the paneling takes around 4 hours. This supercar has been fully covered. Later on, it will demonstrate what it's capable of. Each chiron has to complete a test drive of around 350 kilometers before being delivered.
We do the test drives with a protective film in the car and the windshield. It takes half a day to cover the chiron with film, but it's up to us not to damage the car under any circumstances. We want to deliver a perfect vehicle. Over these 350 kilometers, we simulate all the driving situations that the customer might encounter. Villages, country roads, mountains, freeways, and of course, we have rented the airfield in Colmar to test everything that's not allowed on public roads. Only then can the customer safely drive the vehicle at its top speed of 400 kilometers per hour.
So that he can do that, the quality tester now climbs into the driver's seat for around 5 hours. The cockpit is also fitted with protective covers. The tester additionally wears gloves so that no marks are left on the sports steering wheel. The tester tests different factors such as performance, the individual drive programs, and the background noise in the interior of the Chiron. If a leather seat so much as squeaks when cornering, the test driver notes this defect in his log. The tester then turns onto an airfield. Here, he immediately takes the Chiron up to its limits. He communicates with the tower crew by radio because air traffic is still operating, and that can quickly become hazardous. The stormy weather also makes conditions more difficult. The test driver quickly drives up to the start of the 1.6-kilometer-long takeoff runway. Then he's given the green light from the tower. The expert hits the accelerator. He accelerates the hypercar up to 300 kilometers an hour in around 13 seconds. However, the primary objective is not to test the top speed, but to get the Chiron to develop its full output of 1,500 horsepower. Due to safety reasons, the sports car is governed to 380 kilometers an hour. This special key can be used to accelerate it a further 40 kilometers an hour. As soon as the high-speed key is engaged on the left of the driver's seat, the vehicle checks all of its systems fully automatically. Because at over 400 kilometers an hour, any defect can immediately prove to be fatal.
The Chiron is wonderful to drive. It is incredibly stable when you switch from left to right. Its chassis is also fantastic. It responds to any road conditions like a dream, as if you were skiing.
After the stress tests, the Chiron is taken to the company's own washing facility. The hypercar can only be delivered to its new owner when it's absolutely spotless. Bugatti, the French sports car manufacturer, is an absolute superlative. At 12 high-end production stations in Molsheim, 20 elite mechanics produce the fastest, most exquisite, and most extreme hypercars in the world. With multiple world records, the French extreme